Hi, everyone. Welcome to this working group serving meeting today, August 14. This meeting is being recorded and will be uploaded, so please follow all CNCF standards and behave with each other. And welcome. Happy to have you all here. So let's start with the workstream updates. Do we have anyone from orchestration here?
Yeah, I can give a quick update. So I think we finalized the folder structure for the serving catalog, and I think Eduardo and Abdullah and Jason from Google opened the PR to initialize some of the examples in the core folder, basically using the vanilla Kubernetes YAML. And I'm also planning to add a separate folder for Kserve, and we'll probably start adding examples in that directory as well. I don't know if Jason or Abdullah, are you here? Anything to add?
Yeah, I'm here. I think just following up with some of the comments on the doc in later PRs, and then I have more examples ready to go in the core folders as well.
Sounds good. Thanks.
Thank you, John. DRA?
Yeah, as far as I can tell, there is not much happening right now. Maybe I don't know if John is on the call. As I mentioned last time, we need to start rehashing documents that we had on requirements for DRA, like what we can ask. I plan to do this mostly like beginning of next week. I'll start rehashing it and see if we can ask for anything else from DRA. Right now, the plan is mostly GA, whatever is already implemented in 131. We may need to have more scenarios.
Thank you. For auto-scaling, Ray just pinged me. I don't know, are you here? Did you make it? No, I don't see him on the chat. Yeah, so for auto-scaling, we have a pending 2.0 conversation on model caching. And the idea is to bring that conversation to the main meeting. So hopefully, if we have time, I see Ray comment on open topics.
Yeah, I added that topic for Ray, and I also want to mention that Kserve also has a similar proposal. We can discuss further later on.
Okay, yeah, awesome. Yeah, the idea is that a couple of weeks ago in the auto-scaling meeting, we started the conversation on model caching, and we decided that it would be good to take the conversation to the main meeting to get some feedback. So yeah, that's where we are in auto-scaling. Multi-host.
Shashin said he was unable to make it today due to a conflict. I know one topic is network topology for multi-host networking, and that's been the subject of several previous discussions around multi-host. So I think that's a good intersection point with DRA. Sergey?
Yeah, I think multi-host is one of the things we can ask for DRA. Indeed.
And then I don't know what other topics were there. Does anybody else have a list? I know there's been some work on leader worker set supporting Llama 400 and some ongoing discussions about features for leader worker set, but I don't know if anybody, I think unfortunately we are also missing the folks who work on that this week. A lot of conflicts this week. I think everybody's out on vacation. Go ahead, John.
Yeah, so our team from Red Hat is working on a proposal to support multi-host in Kserve. So we'll be presenting in tomorrow's Kserve community meeting if anyone's interested in joining.
That'd be great. Can you add a link under the workstream update to
Yeah.
where
I'll do that.
how folks would know to join and where?
Yep, I'll add a link.
Thank you. I guess the floor is yours, Clayton. Open topic number 1.
Sure. And this was a very short topic, but since last week, had a fair amount of discussion with folks who are interested in the ecosystem beyond ByteDance and Google, and so I asked Kellen to draft a proposal that we would open as a PR to the working group serving repo. We should probably create a proposals directory and sort out the machinery of how we want to do proposals, but and what we want to see in them. I know we were talking about just copying the structure that device management and batch have used for proposals. But I think it deserves a discussion about how we want to do that and then turn that into a public proposal that people could review if, and then the outcome obviously was once we have a proposal that it becomes appropriate to request a project repo and get sponsorship from SIG Networking. So that would kind of be the process that we'd be working through. And I think just beyond that, any comments folks want to leave right now, please leave them on the doc shared with the community. And then once we have the proposal up, I think the proposal will become the steering element just in general. But a lot of the proposals in other working groups tend to follow the KEP structure, but a little bit more lightweight. So I would expect some of the design details to move in there and that become the proposal of record. So leave comments in the existing doc for now. And then once we get the proposal up, we'll start moving people to that. That's it.
Should we also move the existing proposals from Google Doc to the repo? Or maybe we can just provide a collection of links to the Google Docs?
I think that makes a lot of sense as well. I don't know what the experience is from other working groups. I know with KEPs, a lot of times people draft everybody does it slightly differently, but often proposals that become KEPs start as Google Docs or other forms of docs. And then the moment that we're ready to move to a more formal review process, they go to a KEP form. So we've been using docs mostly, but I think it would be a good idea to get people to translate other proposals into the form in the repo, which enhances discovery. And maybe, as you say, like maybe we could create a list of docs that have not yet made it into proposals, maybe as a recording mechanism. The serving meeting notes have kind of served as that, but they're kind of hard to find sometimes.
Yep.
So
yeah, we can probably start with a collection of links, and then if anyone wants to volunteer to migrate, that would be great. Yeah, we can have something to start with. Yeah,
I think the working group officially approving a proposal or sponsoring a proposal is formally putting it into the repo as a markdown doc, and we should discuss what our process is once the PR goes up. Does anybody want to take the lead on coming up with a process?
Is there any process we can follow from other working groups?
Device management and batch both have a fairly, I think they have slightly distinct processes, and batch has a longer history of it. So I think we can crib from both of those.
Okay.
And just in case it wasn't clear, the key thing would be a repo and a place to coordinate on a project requires a proposal is kind of what I'm suggesting. And then with a proposal, we can request a repo and a channel for specific subthreads so that we, as projects get suggested, we can go after them individually, especially anything that might have significant development effort that would pollute the main serving channel.
I can work with Callan to make it happen.
Yeah, that sounds great.
Yeah, Q is like the canonical model I'm thinking of is Q, where there is a reason to spawn a small project that then eventually becomes a bigger project, but starting it in its own space has been helpful.
Yeah, it makes sense.
That was it.
Okay, thank you. Okay, so Yuan, you're next.
Yeah, Eduardo, do you wanna kick this off? For me, I just wanna mention that we are from KSEF, we're working on the model cache proposal. So I don't know if like that's similar to what the auto scaling workstream is working on.
Do you wanna go over it or?
No, I don't wanna go over this because we already went over this in the KSEF community meeting.
Okay.
Yeah, just because we said this is something to be discussed with the community, so I just added that to the meeting notes. I don't plan to present anything.
Okay. Yeah, I guess please share the link for the meeting tomorrow. I'm interested in attending that, and I guess others are.
Okay. Yeah, basically the model cache proposal is it's through the PVC approach and making sure like the models can share a PVC. And KSEF also has an existing feature called model cars that's based on OCI. And yeah, so just want to briefly mention that it's available in KSEF. That's it.
Anyone questions on model caching?
Oh, yeah. Yeah, hi, I'm Kaishin, and I'm working on the Ray and Kubernetes in the N-scale. And we recently working on a project named A30DAC to reduce the system overhead from Ray. And our first use case is to implement it for a VLN for the pipeline person. But I just wondering that like the community, is there any guys to have the experience about the serve the large models like the Llama 3.1, and what's the trend for the what's the trend to serve this kind of model? Does people prefer to use integer flow to do a quantization so that it can run on a single machine, or people prefer to use like a pipeline person or a tensor person so that it's run a single model across multiple GPU machines? Yeah, this is my question because we currently implement the pipeline person across multiple nodes. Yeah, but I just wondering that how does the community typically serve this kind of model? Yeah.
I'll say I know that a few comments have been made about being uncertain whether int4 quality was sufficient for this model, but I have very little data at this point. People are still, as far as I know, people are still kicking the tires with this, but I have not seen people share feedback with us about whether the quality of 405 is acceptable at int4 versus int8.
Got it. Yeah, I think maybe we are also very early, so we're currently trying to implement a pipeline person, but we are not very sure what's the trend for it. Will people prefer to run on a single machine or multiple machine? Is the integer for the quality loss is acceptable or not? Yeah, so right, if anyone is interested in that, I am very happy to chat with that. Yeah, and by the way, I think the project that I mentioned is this one. Yeah, we currently just working on this kind of the new API, and the current use cases for the VLN pipeline person, and the other side for the training side also implement something like the pipeline person or the little bubble schedule. Yeah, for the training. Yeah, cool. Yeah. Okay, cool. Yeah, and thanks for Clayton for the answering.
And I can actually comment on that real quick.
Oh, cool. Thanks.
Run that at Octo. So our experience has been, we run 405B at FP8 on H100s. That's the approach that we take, and we found that I don't think that quantizing 405B to int4 will be competitive with, say, like the 8B model or something like that, where you might see the same performance there. I think that quality degradation at int4 will be substantial.
Okay, so currently you use a LPA and on a single machine or
right, unlike a single A3 or P5 on AWS, which is the 8X H100 80 gig instances.
Got it.
Or you could run it on 8X or A100s at lower level of performance, I think.
Okay.
And there's some other architectures, obviously, it can be run on AMD, et cetera. But I don't know if how many people have access to the MI300s.
Okay, cool. Thanks. Yeah. If you're interested, maybe we can talk offline. Yeah, I'm very interested in your hands-on experience.
Certainly.
Okay, thank you. Cool.
I saw a comment in the chat from Rita. Rita, do you want to start discussing that here?
Sure. Again, thanks for starting the doc. I haven't read all of it, so sorry if the question is already addressed in there, but
Yeah, no problem.
yeah, it'll be good to understand the differences and what the OCI volume cap does not address.
Yeah, so yeah, we're talking about two different things here. So KServe KServe has a feature called model cars. That's based on the OCI approach. And that's before the OCI volume was supported in the new Kubernetes release. So that's something we'll be working on, like how to leverage that effort in KServe. We'll be discussing that integration in the future. But this proposal here is based on PVC. So that's from a different, based on a different approach. So for example, for models that are not a good fit to be stored in OCI as OCI images, so we'll be leveraging the volume PVCs for the model cache implementation. Does that help?
Oh, sorry, maybe it was just me. The sound kind of went in and out. So you got cut out right at the good part. Do you mind repeating, or we can also discuss this in the doc as well, if that's easier.
Yeah, we can. I'll add some links to the model cars proposal, and so that you can tell the difference between the model cars feature and the model cache feature in KServe.
Okay, yeah, that would be helpful. Thanks.
Yeah, and we'll probably have more to share in the future once we figure out how to leverage and integrate with the new OCI volume feature from Kubernetes as well. Yeah, that's also a feature implemented by our team from Red Hat. So we are also discussing that internally. So. All right, any other questions regarding the model cache? Yeah, feel free to follow up. We can discuss offline as well. Thanks.
If not, we can give people time back if there are no other topics for today.
Bye. I had a quick question on the KServe model caching proposal.
Sure.
Specifically, I saw in the proposal that there's option one was not being considered. And option one is where you build a custom machine image and you use that for your nodes, was my understanding. And the options that were being proposed were basically loading to a local disk, so that I'm guessing like subsequent model startups or subsequent serving of a given model on that node would come up faster. So if you were to scale down and scale up the model on a node that already exists, then you would see a performance improvement. And then I think the other proposal was a PV that's backed by something like NFS, where I'm guessing you would see a performance improvement when the node scales up initially, because perhaps you'd be pulling from NFS as opposed to pulling from S3 or somewhere else. I was just curious, do we have any numbers on how those different approaches compare? So let's say like, baking in a model into a machine image versus so that it's there in the boot disk, or versus like, pulling from EFS or something of the sort.
Yeah, building into machine image is like a little tricky. Like, so whenever you like every time you update the model or like you change the you have to like rebuild the machine image.
Yeah, it's tricky for sure. I'm curious if there is like, when you're proposing to the end user, hey, use model caching here, it would be good to know like, what is the trade-off between going that tricky route and going the built-in like this proposal route?
Yeah, we haven't test out the machine image, but I guess it wouldn't be in terms of the speed, it wouldn't be faster than the. I mean, just like you have the model baked into the image, it's easier to provision the node, but I think the speed wouldn't be faster than you cache the models on local, right?
Well, on a fresh scale up of a node, I would think there'd be a massive difference, right? Because if I'm understanding the proposal correctly, what I'm seeing is that one of the techniques is node comes up and you cache the model, right? And then you serve the cache model, which if you're auto scaling nodes, like you're not really seeing any performance improvement on the first scale up of that model on that node.
I mean, yeah, that makes sense. Or you have to like bake into the machine like provision to like download those like models first before you mark the node ready.
Or it's just, when your machine comes up, you have the model baked into the machine itself. I'm just curious if there's been any investigation as to like the performance trade-offs of those approaches. I understand like Kserve probably cannot orchestrate, the
machine.
Right.
Yeah.
That's not the scope of that.
Yeah,
but I think it would be very insightful to the end user to know at least what are they trading off for that convenience of using like a Kserve built-in model caching technique.
Yeah, definitely an interesting idea. Yeah,
Hi, this is Fei from so we build Kaito, so we use exactly the approach one. We bake images into we bake the models into container images. So so I think this PVC idea makes sense in the case that if you have some nodes, that nodes is kind of persist. It's like you have full control of the nodes, so you won't easily drop those nodes. So like the same nodes may be reused for multiple models, right? So then you have full control of the storage of PV attachment. So that makes sense. Where in some of the case, like cloud, if you just auto-scaler based, so every time you have a cold start. So regardless you use images or use PV, so you have a cold start problem. So speed-wise, I can give you some numbers. It's like download 40 gig. If you use Azure MCR, takes about 10 to 15 minutes. So that's roughly the number. You can maybe do the math if you consider mount something into NFS, just check the bandwidth, what do you have, and if loading telling from NFS to local memory still takes, I would say, minutes level roughly. So so you do have a trade-off. So I guess PVC may be good for some latency issues, but indeed, it can help in certain cases for management. Sometimes it can mess up things. Where images, can be easily for management, like you have tagging. So just use tags, exactly what versions you are working on. So I think it's just the trade-offs between latency management, flexibility in terms of how do you want to manage those files. So and IAM may be slightly different. So in my opinion, IAM may be a little bit tricky in the sense that it won't be too much changes on the way that you use it. So unlike other models. So this is my opinion. So maybe this is wrong. So that's so otherwise, if you change the images too frequently, yes, indeed you have a problem. So you need to, every time you build huge images, regardless of whatever, it's going to be overhead. So that's just give you some number that we have. I haven't tried this PV case, but if you want to know some numbers, if just download the entire huge images from container registry, we can talk offline. So I can share some numbers with you.
Yeah, sounds good. But one of the questions in my head, I'm unknowledgeable on, is whether or not there are any performance, like built-in performance optimizations in the clouds for that you would get if you were to bake it into the image that you start up the machine with.
Yeah. So images. So first of all, image is a naturally local caching. Just download once. So once the pod restarts, you don't need to download again because images naturally is just caching locally, right? So we only pay from the startup overhead.
I mean the image that the actual node's coming up with, not the container image.
Natural nodes. That's different. We are not doing that yet. So I'm talking about container images. Yeah. So natural node, I think Google has a proposal like secondary boot disk or whatever, so you can bake the entire images into the node images, right? So that's another approach. Well, that requires some changes on container D because you need to slightly change the way where you get the base images. You want to get from local disk instead of from a container registry. I think that's a pretty interesting proposal. We are trying to see whether we can do the similar things in Azure because we also have some image streaming, very similar. Every cloud vendor has something like this. So we are trying to see whether we can do that. That thing again, you shift over the overhead of managing container images to managing disk images. So similar overhead, in my opinion, to understand. If you want to update that images too frequently, you do have some problems in terms of management, right?
Yeah, because these models constantly keep changing. Like you Llama 2 go to Llama 3, and then you will need to rebuild these machine images.
Yeah, for sure.
Or you have to build multiple ones, depending on the model.
Just to share some information to Nick's point of some of the optimizations different cloud providers have done. So this one I know. So Google GKE has this secondary boot disk. And there is also a image streaming feature in GCP that basically kind of streams any container images if you enable that feature. That's sort of like a cache closer to your nodes. I think AWS or EKS also supports bring your own image, or what is that? AWS machine image or something, what they call. So that's what I know.
I think we have some hands up.
Yeah, I'll go ahead and bark here. I just wanted to call out there is actually some functional convergence between a node OS image and a container image, assuming that you've done something. So you could sort of artificially pre-poll images on the node OS image at time of image creation to anticipate that image is going to be referenced in a pod that's scheduled on that node eventually. You can also continually rebuild your node images against what's present on a production VM running in a Kubernetes cluster, which will then have the side effect. So if you have a node with sufficient local storage to cache the images that you're actually using on the pods scheduled on those nodes, then you're going to get some of that sort of operational caching. So you can kind of do both at once, and I've worked with solutions that do that, the latter, the continually reminting an image based on production Kubernetes nodes. Obviously not a trivial thing to operationalize, but once you get that going, then you're sort of taking like regular snapshots of the container images that are actually running on your nodes. So you're optimizing the sort of node bootstrap time, but you're also optimizing that initial pod bootstrap time, assuming that, and then you're also anticipating that pod images are continuously changing. So
And that's I've seen some success with that approach where you bake the model. So baking in the container images into your machine images, and then also baking in your model into the machine images. Startup times on a cold start of a node is drastically improved. I guess in my head, I've always just wondered, now you have a much larger image that's required to start up your machine. And I've always wondered if anyone's ever done the benchmarking on, okay, now your machines are maybe starting up slower, but your containers are starting up a lot faster and your model's being loaded a lot quicker. I'm curious if there's anyone who's investigating that.
What about what we're describing would suggest that the node bootstrapping would happen slower? Like the VM start would happen slower.
That's where
I can actually comment in on that. Like that does happen. It depends on which cloud you're on, I think, and which sort of like or let's say you're on-prem or whatever like setup you're using. But on AWS as an example, EBS volumes are actually uninitialized when you first boot an instance. So an instance will boot on EBS, and like it'll look like your containers are there. It'll look like your model data is there, but it's not. It actually is backed by S3, and it's an unoptimized like S3 backing. So your startup time on a node pulling data from like an EBS volume that's a boot disk on AWS is actually quite slow. And it's dramatically slower than, for example, like it's much faster and we've done the experiment with this and tested like a lot of different approaches on AWS, where the best performance is actually to boot up and then use like parallel copy from S3 is actually faster than what EBS can provide on a boot disk. Now, there's a solution to that, and that is if you pre-warm your root volumes and then have EBS volumes that are pre-warmed, that are pre-initialized, that have that data on them, and then swap them in when you swap those onto the nodes when you boot them. But that's not, I don't think it's an inherent functionality of EKS, but something that could be done. And I commented in the chat that like the secondary boot disk approach that Google has, I think could also be something that if it doesn't already exist in the Kubernetes world, maybe somebody knows of something that can like sort of pre-initialize virtual hard disk volumes for use for this case to sort of get over that challenge of differences between the clouds. And I don't maybe folks have benchmarked this on other clouds. I don't actually know. We haven't done it on other providers.
Seems like in order to get the speed, you do have to like warm up the nodes, right? I don't think there's other good option like magically like
Another thing we discussed before in the more dedicated model or meeting where we discussed, I think it was the auto-scaling meeting where we were discussing model caching perhaps at one point, was the what are they called? Mount volume? Is it mount volumes where you can use OCI images as data sources? And then we discussed some of the challenges around the OCI spec for container images, such as like single-threaded gzip compression and other things that slow down processing of them. So if you're like, let's say you have 100 gigabytes of weights and you're trying to load that through like even with image streaming, you're still dealing with like streaming the data, and you're also dealing with decompressing it in a single-threaded gzip. And so there's some factors there to consider, particularly with the larger models and larger weights data.
Most of the model shards are like around like a 10 gig, I think. I don't think we have 100.
Yeah, actually, we discussed this. I remember this discussion in the auto-scaling work group. We discussed that you get caching out of the box on the host when you package weights as images, because containerd will cache them for you on the host. So you get, when you restart your workload, it will be faster. Or also, if you are a multi-tenant. But the problem that everybody highlighted at that time was that the builder ecosystem is not that great for packaging weights, which are multiple gigabytes into images. That's the problem.
Yep. And layer uploads are single threaded as well, or single, like per layer you can only have like OCI spec is single. Yeah, and the registries on the cloud and such are not very performant either.
Yeah, I'm curious. How is this an extension of the model car, or is this a new something new? Like, isn't this what model car also does caching? Is it not? Does it not do something similar?
Yeah, this is something separate. This is a different proposal.
But model car will also download the model. It also there's a model. I maybe I'm confusing the name. There is I remember reading something on the Kser docs where it would download the model.
Yeah, download the model for each node.
The one is the model caching. That's the that is for like caching the model, like using local volume. And the other model car is based on the OCI image. So you basically bake the model into the container image.
Yeah. I added a link to the model car proposal in the meeting notes in case you're interested.
It's basically two approach. Like one is baking the model into container, the other is still separate, but you cache the model locally. Use local PV and PVC.
Jeff, to your point, realistically, all approaches that we discussed, like secondary boot disk or image streaming, they all unpack all the images first, and then like all the layers, and then serve. I mean, they're basically eliminating this zipping unzipping portion of OCI image.
Right. I think the initial part is the pole, right? Because it decompresses at the pole. And so that's where you get some time. You get like you're going to peg a single CPU really with like the initial decompression, right? Or the boot disk. Sorry, the boot disk bypasses that. Yes, but then you have the data transfer speed on uninitialized volumes is the bottleneck at that point.
Exactly.
It's particularly with EBS, but yeah.
Yeah, but my question perhaps is OCI image is like compression. Like compression is not ideal in OCI image. Is it really a bottleneck with all the technologies that we have like on top of it, or I mean, do we need to change OCI or like come up with different format to allow parallel zip unzip, or we fine with compression format in general? We just need to compress it in different time. So
I also think like the spec doesn't prevent us from using different compression techniques. I think it's the publishing tooling and the other side of it that where there's more where it's more problematic. So yeah, the compression part I point out just because like people run into that if they don't think about it or don't know about it. But it can be solved. It can be solved. The OCI spec doesn't prevent you from solving that. The publishing side of the OCI spec is where there's problems in like having large data in OCI layers because of the aforementioned like the spec. Like for example, most registries won't allow you to parallel upload a single layer, which is something that seems like an easy extension to get bought into on the spec potentially. If we just to help with if people want to use larger layers and such. However, yeah, I'm not sure. I've never engaged with that group on that.
Try to find contacts. Okay.
Some other things from our perspective, which could be, interesting to the group, is that I think there's sort of kind of two big use cases here, right? There's the enterprise or business or like smaller deployments where they're going to use like a handful of models and a handful of LoRa's. And then there's somebody like us who's a provider who's going to run tens or 20 or maybe hundreds of models and checkpoint variations, and then run maybe tens to or like hundreds to thousands of LoRa's, and how we move those things around. So I think there's definitely this group. I mean, maybe we can sort of like give some attention to both of those realms. But for us, for example, even if we were to pre-bake our machine images with some of the popular models we use in them, if some, let's say we're using like 4 GPUs on, we have 8 GPUs per node, and we have it split in half, and we have like 4 and 4 for 2 different models. And then let's say like a new model comes out and we need to reallocate those scarce resources to like swap out with another model. Now we need to get that model on there. We need to be able to like to do that quickly and with high performance. So pre-baking the model into images in that case for us kind of adds like an extra friction to us being able to more dynamically manage our infrastructure. But especially when a new model, let's say like something new comes on the scene, or some new set of like hundreds of gigs of weights data comes onto the scene that we need to move, that we need to get there in a rapid fashion. So I think about it from both perspectives. I think we could, if there's a way to bake images where it solves the case of like, it solves the case of the most common models at that time, and then the other stuff kind of is just a little bit slower. That's also potentially interesting. But just some, what are thoughts on that in terms of the sort of multi-tenant provider layer, like side of this, and versus the customer cluster or the enterprise cluster or business cluster? I don't know if you have any thoughts on that, Sergey.
I think the hope is we'll see more customers having like one huge LLM model and then a bunch of LoRa extensions on top. And in this case, dynamism is easier to achieve. If you have many models that you need to, I mean, even secondary boot disk in GKE right now, it only supports attach on creation, right? So we don't attach later. That would, like, if you about to use like secondary boot disk to minimize the load time of models and like distributing them faster, GKE doesn't support it with secondary boot disk at the moment. We're thinking about it, but it's lower priority for us right now. So definitely different set of scenarios here. I don't know how many customers will be like you.
Yeah. We'd also like to, I think most of what we would be participating in is some elements might be useful for our like shared tenancy infrastructure, but the other side of it is we also have a private deployment product, which I think this is more aligned with, like overall the work of the group is more aligned with.
Any other thoughts on the topic?
Yeah, I guess I'll just wrap it up by saying I think from my perspective, it would be super useful to just understand the theoretical optimum performance solution. And maybe it requires a lot more orchestration, or it's at layers beneath, just managing things in the Kubernetes API server. But I'd be curious on if anyone's plans on doing any work there, or if that's kind of space that we should, someone should put in some time into benchmarking different options.
Yeah, I wonder how much of it will be work that everybody doing together, like preparing these images to attach is definitely something that we can do upstream and like find an optimal format for that. But then there is different infrastructures where it all operates, right? So I think it will be vendor specific in many cases, like which way to use it better. That's why I really like the approach that like models are images, and then Kubernetes just defined that like you refer to this image by this version by this SHA, and then there is an infrastructure that does magic underneath that will optimize this pool. So like intention of what you use is separate from how platform will help you achieve better performance.
Makes sense.
It does feel to me that like all the machinery we have for OCI images, like we've already built all of this. We've already built the stuff for replicating data. We've already built the system for caching things. It's content addressable. Like we've already done all of this work. And then like anything else we do is like duplicating that work or like hacking around the fact that OCI like doesn't quite serve this case. And as we all know, like technology like moves fairly rapidly. So like right now, like, yeah, sure, OCI has these problems with like not being able to move this data around fast, but now we have this problem that we want it to for a good reason. So to me, it feels like we're sort of going to be working around that problem until like OCI's just, it becomes solved in OCI and it's no longer a big deal because our compute power gets better, we get things improve, and then we're like, I have a terabyte Docker image, who cares? It just works, like, because it seems crazy to us today, but tomorrow a terabyte Docker image is just a terabyte Docker image. It's like, so that's the other thing that's kind of troubling here is we're all like putting this engineering effort into solving this problem that's going to, that meanwhile technology is going to catch up to on the other side. And then we're going to have this like we're going to have this complex setup for moving weights data around that's like semi-pointless.
I think that's a good perspective.
Okay, I think we exhausted this topic and we can get 8 minutes back to everybody. Thank you. Bye.
Thank you, everyone. Bye.
Take care. Bye.
Have a good day.